Can you explain quantum entanglement communications?
Yes, I don't think most people understand what I'm about to say anyway, but I will.
This video is the top search result for quantum entanglement, both on TikTok and Instagram, and he gets it completely wrong. I'll show you, then I'll distill it down in a way that you'll then be able to confidently correct all of your friends.
You can take two particles, quantum entangle them, and then take those two particles and move them at any distance. And if you then rotate the spin on the one electron, if you modify it so that its spin changes, the quantum entangled electron at any distance will simultaneously, in no time, switch its rotation also because they're quantum entangled. So these communication systems are taking advantage of this aspect of quantum mechanics that most people can't wrap their heads around, and this is what they're utilizing. It's just the new level of science that affords us the ability to communicate at any distance instantaneously.
So wrong. It was proven back in 1978 with the no communication theorem that quantum entanglement does not allow for instantaneous communication faster than light speed. Entangled particles are not tied together in a normal sense. If you change one, that doesn't magically affect the other. Here's how it does work. You can get two quantum entangled particles by doing something like splitting one high energy photon into two lower energy ones, but in a weird sense, still sort of both parts of the same particle. Each part has a quantum spin that, when measured, can land either up or down. But if one lands up, the other will land down. Here's a two-step analogy. First, imagine you flip a coin, but inside of a box. Something inside then splits that coin halfway down the middle and separates each half into two smaller boxes still sealed. We each take one box, and you go all the way off to Japan, and I get jealous because I really want to go to Japan at some point. But at any point, you can look in your box and see if that coin is either on heads or tails. And as soon as you do, you know that when I look in my box, my coin will be the opposite. But nothing you do to that box or that coin will change my coin. But that's not quite entanglement, because what makes it really weird is that until you look in that box, the coin is neither heads or tails. It's still spinning. It's as if we had two spinning coins and a wizard came and cast a spell on them, making it that whenever the first one lands, then when the second one lands, it will land in the opposite side of the first one. For each of us where we are, it still seems like a random result. We can call heads or tails and use that result to see which team goes first. But we know that the other coin, whenever it is observed, will be on the opposite side. This doesn't technically transmit any information, but it can be useful in communication for things like cryptography, secure communications. Because if I have 5 coins entangled with yours, when I observe them and see the pattern, I can then use that code as an encryption key that only you can observe your coins and know the reverse of, and use it on information that you get. We can cover more of that in another video if you want. Who understood? I've got more analogies.